Okay, so hello everyone. Today we will be solving some problems from C++ STL sheet from our senior website, and we will be solving this F update range. So let's start by understanding the question. So the question says that you would be given an array of size n and you need to answer n queries. Now, what are the n queries? So in each query, you need to add value from the index L to R. So for example, let's take this. So this is the array which was given to you. So 1 0 1 0 1. This is the initial array. Now these are three queries which were given to you. So these were like you were told that add the value, like it is given in LR and value format. So add the number one in the range from what, 1 to 2. And let is this one base indexing or zero base indexing? So I think it's a one base indexing. Okay, if I'm not wrong, yeah, it's a one base indexing because L and R goes from 1 to n. So now let's execute the first query. If you execute that, add the number one with from the range 1 to 2. Okay, so if you add one here, so then new array becomes 2 1. Then this is unchanged. Okay, 1 0 1 is unchanged. Then you perform the second query, that is add value 3 to from range 3 to 5. So the range 3 to 5 is what, 3 to 5, this is the range, and you need to add the value 3 to them. So the new array becomes 4 3 and 4. This remains unchanged. Now you needed to add value 2 to the from the range 1 to 5, so you need to add from the to the whole array. So it becomes 3 2 5 4 5. Sorry, you needed to add a value of 2. My bad. If you add 2, you get 4 3 6 5 and 6. Yep. So this is the final answer, which is also occurring. So you need to print this array. Now the obviously the first brute force approach would be, for each query you just iterate from that L to that R and just update with that value. So you add that value, add that value from that way. So the time complexity would be, for q queries you would be iterating to the whole array at max n times. So time complexity would be this q times n. But if you see the constraints, n and q both can range up to 10th power 5, so that would become a TLE. So you need to optimize that. So to optimize that, there exists a concept of difference array. So what is a difference array? So just forget this. Okay, imagine that you were given this array. It's let's say it's like, imagine this is an array, any imaginary 1 2 3 1 5 and 8. Now, if I just told you to add a particular value, let's say add a particular value of, let's say, x. Okay, add this from the range from here to here. So what can you do? So imagine that if I denote, or maybe if I add just a value of plus x, like if I just add a value of plus x to this, the starting value of the index, like if I am told to add the value from L to R, and if I just add the plus x from the in the starting value, and so this is the L to R range, right? 3 1 and 5. So and if I just subtract this, like sorry, if I just add a negative x, right? Adding a negative x or subtracting x is the same thing. So I subtract x from the in the rth r, this is rth index, this is r plus 1th index. So if I do this and I take the prefix sum, so what happens? So if I just take the prefix sum, like from this part to this part only, so what happens? I added this 3 plus x. So imagine that x is here as 2. So like I added a 2 here and I subtracted a 2 here, like in the rth, and I do the prefix sum. So it would be plus 2, plus 2, plus 2, and 0, right? So adding 2 to these values or denoting by these two values, both happens to be the same. So what can you do? Initially, you have this array, correct? And you just according to the queries, you just by this difference array concept, you just add the value at the array at lth position. You do plus equals to x, okay, and array at r plus 1th position, you do minus equals to L. So, and at the end, if you just take the prefix sum, your answer would be there. So let me code by side. So uh, this was the size array, and let the queries were q. So let me take the vector. So I input the vector in the vector v. Now for all the subsequent queries, what can I do? I need to take three values, right? I need to take L, R, and value, right? Now, if I take these all parameters, two things can happen. So, like I just need to add that value in the array part, correct? So now, what can you do? Either now you can just uh, add it in the prefix, or maybe add it in the vector part itself. So vector of L. So it was a one base indexing, I guess. So just subtract L and R, like do minus one. So L plus equals to val, and V of R plus one at index, right? Minus equals to val, right? Also, you need to take care of this thing. So if you are doing this R plus one at index, so for better, like it would overflow right here. So you just what you can do is just take this n plus 1 size index and continue the same. It would handle that, and at the end just take the prefix sum. Okay, so if I just take the prefix sum and I just output the vector. So let me execute this. 4. Okay, maybe I made some mistake here. uh, Okay, I was printing the whole array, right? So, like, I needed to print from 0 to nth index only, right? Mm, 4477. Okay. Why is this wrong? Let me check. Uh, okay, my mistake. I found it. So, like, I was doing in this, right? I was incrementing in the vector itself. So, that is obviously wrong because if I just imagine this is the original vector, right? If 10101. So, leaving this all would also denote, like if I just do like plus 3 minus 3 here, so this would be wrong, right? Because in the vector only if we are doing, so it would mean that uh, this is the, so originally we needed to take a prefix type of which with an empty vector, right? So what can I do? I can just now take this in the one base indexing array, and let me create a operations vector in which it will denote what all operations to be there in the n plus 1th. Okay. Okay, n plus 2, I guess. Yes. So now no need to do one base indexing. So I can just do what? Operations at L and add operations at R plus 1. The same thing which I did here. And instead of taking prefix of in the vector itself, I need to take in the operations vector itself. So, and at the end, I need to check, like, just need to add what all operations were there. So v of I plus equals to operation set I. Yes. Now if I just print the whole vector, I would get my result. 43656. Yeah, indeed that. So let me check by submitting that. Okay, it's running and hmm, I guess the server is slow now. Uh, Server is slow, but indeed it would pass because you have done it correctly. So, yep, it would eventually pass. Maybe there is some system testing going on to it, so that's why. Um, So you understood the concept, right? So instead of incrementing in the like array itself, you can just create an empty vector initially. This an empty vector indicating you have not performed any operations, and you just add subtract these all values. At the end, you take the prefix sum here of these operations operation vector, and at the end you add it in the answer vector. So find like original vector which was here. You add this prefix vector and get the result. Okay, it will indeed pass because it has passed these many test cases. So thank you for listening. Thank you. Bye bye.